Hi guys, it's me again, Miss Finn. I'm so sorry I'm not there again. I still am in New York, visiting a charter school, Harlem Village Academies. I can't wait to tell you about my visit. When I come back, I will fill you in all of the details, and I expect you to tell me what's been going on in the classroom. I hope you are getting a lot out of my videos, and if you have any questions, I hope you know that you should be emailing me at any point in time. So we're going to go ahead and jump into lesson 4.3, which begins on page 135 in your textbook if you'd like to follow along. Let me get there. So for this lesson, the objective is to be able to solve equations with variables in both members. What that means is you're going to have a variable in the left member, or the left side of the equation, and the right member, or the right side of the equation. So let's go ahead and do an example. We'll start off with a pretty easy one. 3x plus 55 equals 8x. Okay, oops, let me move this so that you can see it. That didn't help. There we go. Now, let's understand first of all what I mean by both members. Here's the left member, and we do have a variable, 3x there. And here's the right member, and we do have a variable there with the 8x. Now, how am I going to solve this equation? The goal is pretty simple. The goal is still to combine our like terms. And even though our like terms are 3x and 8x, the problem that we're facing that's a little bit different than any other problem is that this time the 8x is on a different side of the equal sign than the 3x. So how should we solve this? Well, the first step is going to be I'm going to subtract 8x from both sides. When I do this, I am left on the left side of the equation with 3x plus 55 minus 8x equals, and 8x minus 8x is just going to give me 0. Now, this kind of looks like an equation from our previous lessons, and what we're going to do is we're going to use the commutative property in order to rearrange it so that our like terms are next to each other. So 3x minus 8x plus 55 equals 0. When I combine my 3x and my negative 8x, I'm going to get 5x. Negative or positive? It should be negative, absolutely. Don't forget that negative sign, very important. Plus 55 equals, oops, see if we can lift this up a little bit, equals 0. At this point, I'm just going to solve it as a regular two-step equation by subtracting 55, giving me negative 5x equals negative 55. I'll divide by negative 5, giving me x equals positive 11. Oops. Hi, Algebra 1 students. This is my dog, Tanner. Tanner, can you say hi? Tanner, say hi. Tanner's very serious, apparently, today, but I thought you all would enjoy meeting my dog. He is very cute. He's 3 years old. He's a French bulldog. And he's kind of like my child. He has been very helpful while I've been making these videos. Whoops, I think he's ready to get down. We're ready to start our next examples. Okay, I thought we'd go ahead and do some more examples from section 4.3 before moving on. Suppose we have 5 minus 9x equals 9x, or negative 9x. First thing I'm going to do is I'm going to add 9x to both sides. That's going to give me 5 in my left member equals 0. Here's the question. Can 5 ever equal 0? No. So the answer to this problem would be no solution. Now suppose we have the problem 4 parentheses x plus 3 equals 3x plus 12 plus x. Okay? Let's go ahead and start with our distribution. That's going to give me 4x plus 12 on my left member. And over here I can combine the 3x and the x to get 4x plus 12. Now, the thing is, in this one, you have the same exact members, the same exact values on each side, right? So what we're going to say is that the answer can be any number. It's not necessary for you to do any more steps once you have shown that the two members of the equation are exactly the same. I'm going to say that one more time. It is not necessary for you to do any more steps once you have shown that the two members of the equation are exactly the same. I hope this is helpful.